Hi, I'm Gaurav. I run Nond Systems and we build and deploy agents for our customers. In this video, I'm walking a friend of mine through how AI agents actually work, from basic React loop to tools, guardrails, and real code. Just a real session with a real developer asking real questions. If you found this valuable, please share this with others and subscribe to the channel for more such sessions. Thank you.
So the recording has started. Tell me, where do you want to get started from?
As a layman's language, right? First thing first, we heard so many things about AI everywhere. Now buzz is coming as AI, agentic AIs and all this stuff.
Hmm.
So can you put a light on how agent or agentic framework help a normal UI developer or a normal coder to his uh, day-to-day work?
Okay, makes sense. So mm, let me share my screen, right? And let's start from the little bit beginning, right? So
Mhm.
a bit of context. So initially, in 2023, ChatGPT came out, right? This was what led to the AI thing, the hype. Then in 2025, that's when DeepSeek came out, right? DeepSeek, a Chinese model, right? Beginning of 2025. So Jan. So this is where the actual agent hype began, right? Before that, it was workflows. What we used to do is we had a normal workflow, if else, right? And in between some places we used to add ChatGPT. But after DeepSeek came out, then the what they proved was you can actually train reasoning models at a very cost-effective rate, and that's where the agent began. So what is an agent? So you have two things. So one is a model, right? So examples are GPT 4.0, right? Which was like the pretty famous one. Then there is Claude, Sonnet, Claude Opus, right? So these are models, LLM models. Then comes your agent. Agent uses a model, right? So it could be any model. It could be GPT, it could be Claude, it could be Gemini, right? It could use any model. Is it clear so far? The,
Yep, I'm following you.
yeah. So now if you look at the structure of an agent, right? What is an agent? Agent is nothing but a, so there's a term called React loop. So this stands for reasoning and act stands for action, right? So given a problem statement, the agent decides, it reasons over how to solve that problem. And then it takes actions based on its reasoning. And it again goes into the reasoning part. So it's a while loop. So in normal programmatic constructs, it is nothing but a while loop. Right? So while agent has action to take, right?
Mhm.
Take action, send action result back to model, right? So while model has action to take, so first to take that action, and then input to model along with actions it can take, right? So this is the pseudocode of an agent, right? So user enters a prompt, a task, then it sends that input to the model along with actions it can take. And then model reasons over it and it outputs some actions. Then your agent code, what it does is it parses the agent, the model's output, right? It identifies the actions, what the actions the agent wants to take. It takes that action, whatever output is there, it sends it back to the model. So, for example, if you look at a GitHub Copilot or any coding agent, this input is your programming task.
Correct.
Right? Model is, let's say, any model that GitHub Copilot or GitHub Copilot provides. What are the actions it can have? So GitHub Copilot or any coding agent essentially gives 3-4 actions to the model. So one action is read a file. Second action is write to a file. Third action is execute a bash or shell command or a command prompt or PowerShell command. And fourth is use search. Text, full text search, right? So for example, they use either grep or rip grep, right? So command prompt has the search commands, right? Terminal and shell, everyone, especially the Linux world. It has grep. So these are the basic 4 commands that any coding agent requires.
Correct.
So when you say, okay, go and fix this bug, you give some information to it. So the model now decides, okay, let me, it tries to identify first the keywords in the description you have given, right? Then it searches for that keyword in your code. It gets a few files. So that is the first action.
Yeah.
First action is search. It gets some results. The search results are sent to the model. Then the model says, okay, these first 2-3 file results seem important. So what it does, okay, now the next action it will say is read these files. Then the agent, what will do is it will take that action. It will read those files and send it back to the model. Now the agent has the context where the bug could be. If it finds in its reasoning, if it finds okay that these files might have a bug, might have the root cause for the bug, then it will call a write file with the code fix. If it thinks that it does not find the root cause, it will again read more files as long as it does not find the probable area where there is a bug. So that's the coding agent that we use every day. Now, obviously, there are a lot of optimizations that if the file is big, then the agent will not read the whole file. It will read only a small section of the file between given line numbers. So now the action definition is nothing but a JSON, right? So for example, you have read file action, right? So this is called a tool in terms of agent. So what it does is it's a JSON. Type is function, right? Input params. What is the input that this function requires? And then what is the output? What output this function can return? So the input here for a read file can actually be file path or file name. Then it can be line range. What range of lines do you want me to read? Right? So these can be different input parameters for that function. So then what action the model suggests, it gives out this JSON structure, which your agent parses, and then it knows, okay, so then it knows, okay, I need to call the read file function. This is pure function in your programming language, right? So I need to call the read file function. For that, I need to pass the file name that I want to read. I want to pass the line range that I want to read in between those lines. This JSON the agent will send, and that's your the model will send. Your agent will read this, call that function, and send the output back to the model. This is the agent in very basic terms.
So, as per the whatever you explained, there are two terms. Like one is model, which calls the agent, and agent
No,
gives the what?
Agent calls the model.
Okay,
Model is the
agent
brain.
calls model
Is the brain.
Brain. Model
So,
is the brain, and agent is the actually whatever outputs we want. So, model can call multiple agents.
no. So think of this like this. In your body, you have a brain.
Okay.
But that brain cannot live on its own. For the brain to get its nutrients and to process information, it needs your body.
Body, correct.
So your body has hands, right? So if it wants to feel something, it will use your hands to feel something. If it wants to go from here to there, it will use your legs to move from here to there. Similarly, agent is the body, model is the brain.
Agent is the body, model is the brain, correct. Now, as a software engineer or anyone, first where we start, like now we understood the agent and its concept. Okay. Now, as per your guidance or anything, where do we start? Start building the model, start building the agent, or we start consuming the agent first, and then we think of building the model.
So model
And sorry, agent.
so model you cannot build right now. It takes a lot of hardware and it takes a lot of time. It's kind of a research activity. What you can start doing is use existing agents that are out there. So there is GitHub Copilot, there is OpenAI Codex, there is Cloud Code. There are many such open source agents that we can start using.
Okay.
That's once we start using those agents, we start seeing limitations with that particular agent, for example. And then if you want to like fix those problems, you build your own agent.
Okay.
So for coding, there is no point in building an agent today. There are a lot of agents out there. But you should anyway still build an agent to get a feel.
Okay. Now, actually, what are the like you explain? Agents can do like code optimization and all this stuff. So, for particular use case, is there any library or is there any uh, the, index where we can find the agents which are available for particular task?
So as I mentioned, agent is just this while loop.
Yeah.
This is from where it starts. This was in 2025 beginning, right? Now, there are a lot of optimizations inside this. Which files to read, which files to not read, right? What actions are allowed by the agent. So for example, you don't want it to run delete commands, or you don't want it to run migration commands,
Mhm.
right? It might screw up your database.
Mhm.
So that's where the optimizations and guardrails come into picture,
Okay.
right? So
Mhm.
uh, obviously you don't want your agent to run database migrations without you approving it,
Correct.
correct? You don't want it to, let's say, perform some actions, for example deleting something permanently from your system,
Okay.
right?
Mhm.
You don't want it to browse randomly on the internet, correct?
Mhm.
Because you don't want it to install any software or package without asking you,
Correct.
especially if you're working, it's a company laptop, right? Even for your personal laptop, you don't want it to install some random node package or random freeware onto your machine, which could have a malware inside it.
Correct.
So these are the guardrails. So
Okay.
initially there were no guardrails. And people started understanding, okay, these are the problems. Then they slowly started adding permission models here. So for example, if action is execute command in command prompt, and it is running npm install, then block it. Or you ask the user permission, yes or no. So then people started adding those things inside this while loop. If it's a database command, migration command, you add a check here. If it's a migration command, don't run it, ask the user. Let the user say yes, then you do it. So then this while loop starts becoming complex,
Okay.
right?
Understood. Yep.
And you can also optimize. So this costs money, API
Mm.
tokens, right? LLMs are built on tokens, input tokens, output tokens. Tokens are essentially what text you send in. Output tokens are what text it generates. So you want it to be optimal. You don't want it to, like, for example, read a lot of files unnecessarily. You know which file has the exact issue. Then what you do is you tell it you should read only this file. In GitHub Copilot, we can tag files, right? At the rate file path, file name. So then that constrains what the model should read.
Then just a basic question like this. Okay.
Mhm.
How agent is different from the our factory pattern outputs or factory pattern design patterns, where we give one output and based on the input we get particular output, right? So how a agent is different from our design patterns, like some design patterns, combined design patterns. It also gives the nearly same thing. It takes the input, based on the input, it processes the data, but it has a constant, like it is only can do a particular task based on your inputs. But that covers the most of the things, right? So what advantages we get from the agent?
So the design patterns, in this case, the factory design pattern, it is deterministic, right?
Mhm.
So for a given input, it will always give the same output.
Correct.
Models are not deterministic.
Mhm.
So it decides what action needs to be taken later. Do I need
Okay.
to run the build command, or do I need to edit the file again? Do I need to find the documentation of that library which is causing issue? That is not fixed. If it was fixed, then you could have written a workflow and you could have been done with it, correct? But here
Okay.
it requires some judgment
So,
or intelligence, which cannot be like put in if and else conditions, which cannot be
okay.
defined as binary conditions, right? There is someone who is deciding.
Mhm. So, as per this one, if we have defined workflows and defined tasks, it is always better for the with our conventional methods and all the stuff. But if action to be taken, or it is a deterministic, or it is vague, like we don't have a defined workflow and it will be evolved on fly, then we should go with the agentic framework where the each output will be defined based on the input and its outcomes. Is that
Right?
summary correct?
Yes. If it is, you know the exact logic to get there, right? Then it's a workflow. It's deterministic.
Huh.
But if even if you know exactly how to get there, but the inputs are kind of changing, right?
Mhm.
Then it requires some judgment or intelligence. So, for example, you're, let's say, parsing documents.
Hmm.
Now, the document is a Word document, for example, or a text document. Let's keep text document easy.
Hmm.
A .txt file. You are trying to, let's say, extract some value data from that text document.
Hmm.
You are extracting name, you are extracting phone number, you are extracting address, for example.
Hmm.
Now, if it's a fixed format, you can do it. You can do deterministic. You can put regex there and extract it. But if someone else is sending you the document and there is no exact structure out there, so someone says, my name is Gaurav. Someone says, I am,
I am correct.
someone says, I am Gat Gaurav. Someone says, like in the James Bond style, I am Gat, Gaurav Gat.
Hmm.
So it's very hard to create regex uh, to extract that data. Simple use case, you are taking a loan from a bank. Someone is taking a loan from a bank. Uh, they they fill the forms. There is a model that does the screening and it does the modeling, risk modeling. A lot of times in the KYC itself, there is some spelling mistake.
Hmm.
So your Aadhaar card or your PAN card has your father's name, but your other document does not have it. Somewhere it is first name, last name, somewhere it is last name, first name. You cannot cache that deterministically. That agent helps here. So what you so there are, does that make sense?
Yep.
And so there are two architectures here, right? So one is workflow, the thing that you're mentioning. It is deterministic. The second thing is there's an agent where inputs can change. The asks can change. In that case, you need flexibility. There is another case where the workflow, the logic is static, but in some places, in some steps in the workflow, you need judgment, right? So I gave this loan processing example. So the workflow remains the same. Read the document from here, extract the fields, and enter it into some database or send an email. Only the middle step where you're extracting information from the document actually needs some intelligence. Rest all the other steps in the workflow are straightforward coding logic. Correct?
Yep.
And that is the most cost efficient thing. Agent is not very cost efficient.
Hmm.
So the problem statement is clearly defined and it does not need any intelligence there. You can just put regex, you can put equality checks there, then use a workflow.
Okay. So just based on the recent conversations, can you put a guardrail or steps where we exactly can use the workflows and where it should be agents will be used optimistically. It's like summarize. If I say like where whatever you said, right, the workflow kind of thing. So can you summarize those? Like these are the steps where we workflow will be optimistic, and these are the steps where these are the scenarios where the agent will be the optimistic one.
Yeah. So I'll share. Can you see a different tab now?
Mm-hmm,
So this is an old article from Anthropic,
mm-hmm,
building effective agents. I'll share this link.
mm-hmm,
But if you look, if you scroll below, they have
mm-hmm,
mentioned workflows are predefined. Our systems for LLMs and tools are orchestrated through predefined code paths.
mm-hmm.
Agents, on the other hand, are systems for LLMs dynamically direct their own processes and tool usage. So I'll share this link with you.
Mm-hmm.
Go through this and we can discuss if you have any doubts here.
Okay.
This is the first one of the first articles where they had clearly called this out.
Mm-hmm.
See, LLM call, take action on the environment. The results are given back to the LLM. The LLM can decide to take more action or it can decide to stop. This is what an agent is.
Correct. Now there
Mhm.
is one that just got to based on the your feedback, this feedback loop, right?
Mhm.
The agent, what is the approach? Like we observed, like whatever agents give output is not 100% foolproof, right? We can see some of the improvement in the each cycle. That's why AI works on, like it improves based on each of your cycle. Each
Hmm.
cycle it improves your uh, the output, but improvement only happens if you get the correct feedback. The
Right.
feedback mechanism is the key here. So
Okay.
how in the whole process where the feedback comes into picture, like what we see in the diagram, like request and response, how a user can introduce a feedback mechanism in that.
Okay, that's a loaded question. It's easy, it's simple, but it's hard to implement, right? That's where most
Mhm.
people struggle. So the agent is only as good as its feedback loop,
Hmm.
and that you have captured perfectly in your question. So, for example, if the agent is writing code for you, but the code does not build itself, it's non-compilable. There are syntax issues there. So the feedback is simple here. You build and you pass the build output, whether failure or success, back to the agent, back to the LLM. That is one feedback. So now the model knows that the build failed. Correct?
Correct.
Second option is, so let's say you're building a web application.
Mhm,
Today, how do you test it? You have unit tests, then you have end-to-end browser tests.
mhm,
Correct? So browser tests, you're using something like Playwright. Open the browser, go to this URL, perform these actions.
mhm,
So that is the second level of check. So first level is build. Second level is, okay, are the unit tests running? correctly? Are any unit tests failing? Assuming build is also successful, unit tests are also running. Now the third thing is, okay, open the browser, perform these actions, and give the output to the model.
Hmm.
So now the browser knows, so the model knows that, okay, while performing these step of actions, the button is not visible on this page. It has to be visible on this page, but it is not visible, or the button is not clickable.
Hmm.
So it gets that feedback.
So that feedback will be implemented into the testing, like unit testing, and then it will get the feedback, right?
Integration testing.
The integration testing and all this stuff.
Yes. So
So,
that is deterministic feedback, right? So that's why you see so many coding agents, because it is easy to verify the output.
hmm,
Other knowledge tasks like summarizing, for example, or searching for question answer over documents, right?
hmm,
RAG, it's called RAG. It's hard to deterministically verify if the output is correct or incorrect.
hmm,
That's where you have domain experts who analyze the agent's performance
mhm.
and identify where it is going wrong. And then they correct the agent's instructions, or they
Okay.
decide to give it more tools to verify its output.
So if I interpret it correctly, some cases the feedback mechanism is taken into the design where the uh, where the deterministic approaches are there, where the feedback mechanism is inbuilt into the system. But in some cases where it is not deterministic, we have to make a provision for the human intervention to give the feedback and loop that one into the system to improve the performance in the next cycle. Is that a correct
Yes,
statement?
yes.
Okay.
So, for example, running coding agent, you see that it is reading the wrong file or it is doing unnecessary thing. You stop it and you tell it,
Hmm.
don't do this, do this.
Hmm.
Or you see that it has written code in a way that is incorrect. You tell it,
But
don't do
that also be to be inbuilt, like that is also a guardrails we have to put, like this is the correct and this is the incorrect. That also we have to define into the system, correct?
yes, which is easy for coding agent,
Conjugating agent.
because you
Yep.
have abstract syntax trees, you have compilers, you have linters, right? Yeah. But for non-coding workflows, it is very hard to put that. So then what people
Correct.
do is they have LLM as a judge. So they use a different model and they ask it to grade the agent's output on a certain framework. Did it call the right tools at the right point? Did it include all the information that was needed to answer the question? So a different model gives a score. So you use that in combination with deterministic checks and human feedback.
Okay. Now we understood the like how agent works, how agentic framework works. So for like a start point, what do you suggest? Where any developer should start using the uh, agents? Like you said, we can use the Copilot and all those stuff for the development purpose. Apart from that, do you have anything in your mind which will give a kickstart to the any first time AI developers?
Yeah. So just a second. Let me. Okay. So let's do something crazy, right? Um, let's just a second. Let's open one agent, right? And can you see my code editor?
Yep.
Okay. So this is Hermes, Hermes agent, which is a open source generic agent. It's not a coding agent per se. It's a generic agent.
Mhm.
It does a lot of things. That is it. It's just code. This is the code of that agent, right? So let's start from here and let's go to Codex, which is my coding agent, right? Let's use a cheaper model for this. See, if you look at, so this is a very good thing, right? So you can see
Mm.
here what command it ran. It checked the current present working directory. It ran a ls command. Then it ran a find command. Correct. It again ran two commands. It ran a search. It ran a read file command. So you're seeing how it's calling tools,
Mm.
right? This is essentially the agent. Here again, it read a bunch of files, correct? If you see here, it gave the start line and end line. So it wants to read between these lines. So this is the main file.
Mm.
Let's open this. Why is it not opening? What's the name of the file? Agent conversation. Yeah. So this is the main file.
Mm.
So let's see. So we don't need this. These are private methods. Run conversation. See. It's setting a bunch of properties for the agent. It is handling different models. It's setting an iteration budget. Like how many times can the loop run? Or else you cannot have it infinite because you will burn tokens,
Correct.
right? Yeah. See, this is the while loop,
Mm.
correct? While it does a bunch of things here. Repair. So
See, this is calling the actions, right? So it's checking if there are tool calls in the output, right? For all the tool calls or actions that the agent wants to take, it does a JSON parsing, right? And then it, where does it call? Yeah, so again, I think this is again cleanup and defensive coding, right? So if the model does not output properly, where is it? 840, right? Why is it not opening? Yeah, this is where it's calling the tools. So the code we saw before was parsing the output from the model to get tool calls and a lot of serialization and correction. So this is generic agent which works with a lot of models. So every model has their own way of outputting the tools. Every model has their own way where it makes mistakes.
Correct.
So a lot of code is given to actually fix that issues. But then at the end, see, it actually makes tool calls here. Execute, right? It's a tool guardrail or decision, right? It also checks if there's a guardrail for the tool. And then it appends back to the agent, the model.
Okay.
So typically what you send to the model is an array of messages. It's a JSON array, which can be either a user message or a assistant message or a tool call or a system prompt. System prompt is the main instruction, how the agent should behave, what is allowed to do, what it is not allowed to do. This is typically the first message we send to the agent, to the model. Post that, user's request. Then the agent either responds or it says, I want to make a tool call. Right? Then you up. So every message that you send and the tool call it makes and the output of the tool call gets appended to the message history, to this array, right? And every time we send this array back to the model with a few more items appended to the end of it.
Okay.
So for starting, what I would recommend is there are a bunch of open source agents. So this is VS Code Copilot chats repository.
Okay.
This is also open source code. You can go and start reading this code. Ask your Copilot itself to explain the code to you.
Okay.
Right? Then there is Hermes, like I told you. You can read the code of this agent here.
Another thing is, so this is an open source lightweight agent which you can extend. You can go and start reading this code.
Okay.
Then there are a bunch of ones like that.
Okay.
There is open code. This is also pretty famous coding agent.
Open code.
Right? So go through these repositories. Ignore this nuanced research for now, it's complicated. Right? But these are like coding agents. Right? You can go through these, and what we can do for our next session is you can probably give me a walkthrough of how these three are different, what things these three do differently from each other. And you can also try to use these two agents also.
Okay.
You can use your GitHub Copilot login there.
Okay.
So you don't need to pay for APIs.
Okay.
Right? So use your GitHub Copilot license that you already have on these two agents. You're already using this Copilot. So these two, use it, debug the code, ask your agent to dig deep into the code, help you to dig deeper into the code base. And for next session, we can actually have a deep dive into how these are different, how these handle different things.
Yeah, that sounds good.
Right? So that's your homework for the next session.
Yeah, perfect.
Any other questions?
Not for now. Actually, this much is enough to digest now. Let me go through the whatever homework you have given, and then we'll continue from here.
Awesome. Let me just stop the recording.